After that, question number 81. Molality of aqueous solution of urea is 3. The mass percentage of urea in the solution is, molality is given, it means m value, small m, that is 3. Let's assume that 1 kg of solvent is there. So if 1 kg of solvent is there, it means the number of moles would also be 3, because we are taking 1 kg solvent, and this is aqueous solution. It means solvent is water. Now, the mass percentage of urea you need to find out. So, mass percentage of urea in that aqueous solution is equals to mass of urea. Moles of urea we have. So, what would be the mass of urea? That is its mole into the molar mass. What's the formula for the urea? That is NH2CONH2. And if you find out its atomic mass, you will find that it is 60 gram per mole. So I'll multiply 60 here. So this is the mass of urea present in the solution. Now what is the mass of the total solution? We have 1000 gram of water, 1 kg of water we have taken. So 1000 gram of water we have, and just add the mass of the solute also. It is 180 into 100. So this would becomes 180 upon 1180 into 100. And if you solve this, you will find that the correct answer is 15.25%. And if it is the correct answer, then we can choose option 4. So the answer now becomes option 4 for this question. After this, let's take next question. Question number 82. Ozonolysis of which compound will give benzophenone as one of the products? In this case, first we need to know that what is benzophenone. Benzophenone is the compound in which 2 phenyl rings are linked in this way, and this is the carbonyl group. We want this compound. If you look at option 2, you will see that this is the compound. Let's check whether it is forming benzophenone or not. We have phenyl ring in this way, double bond here, CH3 alkene we have basically this way. Ozonolysis we are doing. In this case, ozone in this way, ozone we join here, and after that there would be the splitting. In the presence of zinc and H2, this is reductive ozonolysis, and this way there is the formation of benzophenone this way, and the other compound is acetone also. So plus acetone is formed. It means the compound given here in option 2 is the correct option, that is forming benzophenone. For other compounds you can also check. You will find only the benzophenone in case of the second option. After that, question number 83. Consider the following reaction. We have the reaction sequence here. We have this alcoholic group. It is treated with alkaline KMnO4 in the presence of heat, followed by acidification to give you product A. A reacts with ammonia to give you B. B is when heated, it gives C, and further in the presence of bromine and KOH, it is forming D as the major product. We need to just identify major product D. So here is the alcohol, and in the presence of a strong oxidizing agent, that is alkaline KMnO4 in the presence of heat, followed by H2O positive ion. Here is the formation of carboxylic acid. Strong oxidizing agent, that's why carboxylic acid is formed in this way. It means A becomes this compound. Now, when this A is treated with ammonia, NH3, in the presence of ammonia, it forms compound B. Now, what we did, this B is heated. In the presence of heat, it gets changed into amide. this is CONH2. Just recall the name of reaction simultaneously. Now further it is treated with bromine and KOH. This is Hofmann-bromamide degradation, you know that. And here is the formation of the primary amine. This is Hofmann-bromamide degradation, and that's why here is the major product, that is the primary amine that you are obtaining. So here is the formation of this primary amine. Where this is given? This is correctly given here in option 3. So just choose it as your correct answer. After this, there's another question. Question number 84. Most stable carbon ion among the given species is. In this case, we have different carbon ions. And if you look at option 1, 2 and 3, benzene ring is there. It means we have the benzyl carbon ions. But if I talk about this ring that's given in the option 4, this is not aromatic ring. It means stability is least in this case. Now we have to just find out the most stable carbon ion. In the benzene ring, if there is the presence of some electron withdrawing group at the para position to this benzyl anion, then definitely it is stabilized ion. This is most stable carbon ion in which at para position nitro group is present, that is electron withdrawing, and that's why this becomes most stable. If you look at the first option, there is no substituent which is present at ortho or the para position. But if I talk about the third option, here's the group, that is methoxy group. It is not electron withdrawing group. That's why the second option is the only one that is correct for this. After this, next is question number 85. Total number of optically active products formed by monochlorination of 2-methylpentane is. So first we need to check, this is 2-methylpentane. Its monochlorination is done in the presence of sunlight. There are the 5 products that you are obtaining. These are the structural isomers that you are obtaining. In the first compound, this is the chiral center, chiral carbon is there. In second compound, there is no chiral center. Third one, there is one chiral center. Further, it is also producing the chiral carbon here. And in the fifth one, there is no chiral carbon. If you look at any of the compound which has one chiral carbon, it can form 2 optically active isomers. One is dextro, other is levorotatory. Similarly, this third compound also has the chiral carbon, and that will also form 2 optically active isomers. Further, in case of the fourth one, there is the chiral carbon, and this chiral carbon results in the formation of its optical active form, and it will form 2 optically active isomers. So total number of the optically active compounds are here 6, and that's why option 2 becomes the correct option.